All right, I think it might actually be live right now. Usually when I hit start stream, it just it goes to the. I have to go back into YouTube Studio and just be like, now actually started. So, oh no. Anyway, okay. So this video has been a very long time coming. I have had it requested quite a few times over the last couple of months, and I know that I didn't finish the series, so that's what this is. It's the last of the series. So last time in the last video we were reading information from like a Bluetooth device. In our case, it was an ESP32 that was sending, I think it was like movement data, I think potentially across Bluetooth, and then it was getting picked up by an app, and we were showing it on the app. But we haven't done the reverse. We haven't set it up so that the device can react to you pushing buttons on an iOS app. So I think once we finish that, that's kind of rounded out this series, and then this can be the last video. I think the reason why I've been putting it off for so long is because it's a big task. It's different than reading information from a Bluetooth device, because this thing can just advertise, constantly polling, constantly like transmitting information, and then anything can sort of pick it up. It's a little bit easier that way. To send information to it and then have it listen for the information that comes back is a little bit trickier. I hope it's not going to be too long of a stream, but it is. There's going to be a little bit more involved than what we're used to. Okay, so if people are coming in now, hello everybody. So I think what we'll do is we'll just get started on this. You have to bear with me because I do have like separate projects open where like I'll be pulling code from those. So I'll be like switching between screens and stuff. I won't be doing that in front of you. I'll just have to move my cursor off to another monitor, and I'll be, just switching around windows and grabbing code. So what we need for this is obviously our device. So I am using a DF Robot Fire Beetle. It's just an ESP32 board. If I can show you, it is plugged in. Let's see if we can get it to focus. So this is the one I've got set up. There is some code running it from a previous project, I think, but all I'll do is we'll flash it with something else. On the back, I have stuck a battery. So the cool thing about this particular device is that it does take a battery and it can charge the battery. So it's got a charge circuit built into, which is really, really cool. At the top, I have a IMU. So this will be, I think it's 6 degrees. So we've got like a gyroscope and accelerometer in this little chip here. And then on top, there's like a buzzer, like a haptic feedback sort of thing. So these are all stuck together. This was for a different project. Can you even see that on the, yeah, this should be okay in the bottom corner there. There's not too much to show really. So I've glued all these to the board. The only thing we're going to be dealing with today is, I think what we're going to do is we'll send a command to turn on the light that's on this board. We'll just turn the light on and off. Essentially what's going to be doing is just powering that board, because the light comes on automatically. So, and we'll do that over Bluetooth. And then hopefully by the end of this, you will have enough knowledge to go ahead and build your own apps that can have back and forth communication with devices like this. So this covers things like Raspberry Pi and ESP32 and other microcontrollers. So of course, throughout the process, if you have any questions, just leave them in the chat. That's why I'm doing a live stream and not just creating a video. So we can talk about stuff, which is cool. Could be annoying if we go off track for anyone watching the video later. We sometimes on these live streams we talk about things that are just completely unrelated. So, but entertaining nonetheless. So I'm going to start with the sketch file for this. So we have, if you haven't watched the other videos and you just want to like get to the meat of the information on this, I'll cover some stuff again, like I'll repeat myself, and I don't remember what was in the last couple of videos anyway, so there's probably going to be some repetition. So we got Arduino IDE and we have Xcode. So these are the two programs we're going to need. Of course, again, like mentioned, we need our ESP32 dev board. We need to know what board we're using. So up here, you can see we've got, I've got Fire Beetle ESP32 selected. That's not the only change you need to make. So up here underneath tools, you probably have to make changes. Like if you find that the board's not getting flash or getting errors, you have to make changes to the upload speed and the flash frequency as well. From what I remember, this was set to 40. And I think 115,211. Yeah, I think this is the correct. We'll see how we go. Let me just do a quick flash now and see what we can come up with. The other benefit of this particular board as well, not only because of the battery that can be plugged in and stuff, it also doesn't require you to push like a combination of buttons to put it in like flashing mode. It's automatic. Okay, so what have we got here? We've got an error already. Port doesn't exist. Okay, so I think what I've done is, oh, it's the wrong one. It's this one here. Beetle ESP32. This is correct. Okay, let's try that. The compilation time will take longer and longer as we start adding dependencies and stuff. So it looks like we're getting a connection. We have a connection and it is now writing to the device, which is pretty cool. Okay, so this is just an empty project, right? I suggest you do this first up, like just so that you know the board's set up correctly and it's not your code that's broken. So if you've got like nothing in there, you can just compile it, send it to your device, and then that way you can, you know, check whether it's your code that's bad or if there's something wrong with the connection or that. Not all of these cables either will carry data. So sometimes like you'll plug it in and then you'll get like power, the board will light up, but it doesn't have any data pins if you're using like a really, really cheap cable. So that could also be an issue as well if you're trying to like flash something and it's just not working. The cable could be faulty or just not have the capability to do that. Okay. So since we're doing Bluetooth stuff, let's take a look at adding the Bluetooth dependencies. So I don't know if we need all of these, but this is what this other file has for us. And so what we've got is include ble device.h, include ble server.h. From what I remember, there is a difference. So there's the peripherals and then there's servers. So there's different types of Bluetooth devices. Most like you have to like decide what it's going to be, right? It doesn't come manufactured a particular way, in case that was confusing. You can choose whether it's the server or the peripheral. In our case, it's going to be the peripheral, I think, and then the iOS app's going to be our server. So we may not need that server one. Include, and we got another one here, which is BLE29002, sorry. Yep, and I think that's it. This other project that I'm using does make use of another one called, and I think I'm digging myself a hole here if I reveal this, but we got ESP32 OPS. So this is a helper file. So for this other project that I've got off screen, I am doing over-the-air updates. So anyone who watches this later and is like, oh, I want to be able to update from my iOS app without like, because if you want to make a product you want to send out to users, right? You're not going to say, okay, every time you want to update your device, you need to use the Arduino IDE. I think if you're at that point of your device, like you're shipping it out to lots of people and you need to do this over the air, you should be able to figure this out on your own. If you can't, and this is something that like is really, really important to you, please message me and I'll send you some code, I guess. But don't ask me unless you're actually going to use it, because that uses up my time having to go through and do all that sort of stuff. Because over-the-air updates, sending firmware to the device from like your iPhone is tricky. That it took me a long time to work out how to do that. So what you would do is you would have maybe a server set up in the cloud where you've got your website and you've got all these other services and stuff for your app to run. The app could download the update from your server, and then the app could then pass that on to the devices. And that's pretty much how it works with some Bluetooth devices, not all. I'm pretty sure Apple's, any devices that aren't Wi-Fi enabled would need to be updated via an app. So I think Apple's like AirPods and stuff, I think they're Bluetooth. I think they got Wi-Fi as well, but I don't think they connect directly to the internet. So anytime there's like a firmware update with like Apple AirPods and stuff, I think that comes from the phone. It's streamed across from the phone to the device. But I could be wrong on that. Lights like the Nano Leaf stuff, that all automatically updates from like, because it's connected to your Wi-Fi on your router, it'll just pull from their servers automatically. So a lot of devices will just do their automatic updates. And because these have Wi-Fi built in, you could set it up that way as well. But anyway, that's enough for the over-the-air stuff. So we're not going to be dealing with that today. It's a little bit trickier. You have to send it across. You have to break up your firmware into little packets, and you have to send them one at a time. You have to listen for when the packet has been written. And then it's complex. There's a little bit of complex code there. So we're going to avoid that today. So in the setup, well, before we get to the setup, what we need to do is, let me close one of these side panel. That's annoying. Okay, so what we've got here, we need to create a service, like a Bluetooth service, and then we also need to create some characteristics for the service. So the service is like a way to group characteristics, and characteristics are the thing you want your device to do. Right, so our characteristic for this is going to be LED characteristic, potentially like turn on LED. On this particular board, I could have a characteristic for haptics, right? Because it's got a little buzzer thing there. I could say haptics characteristic. Do we want it to buzz or not? Like we can turn that on and off. So, but we need to file these under a service. The service will just help us categorize different characteristics, right? So you might have a device that's got like 10 LEDs. You put them all under a service called LED service. I hope that makes sense. So we go define. Let's put in, let's call it LED service, and let's go with, I mean, we just use any ID. I'm just gonna grab this one. It's like already generated for me. And then let's put a little comment here, because what we'll be doing is I'll make this code available after the stream on Patreon. I mean, you can just download it straight from there and just start playing around with it if you like, or if you don't want to do the whole Patreon thing, you just watch through the whole video and just copy exactly what I'm doing. A little bit more work for you to do. Okay, so we've got our service is going to be, we'll just write services here. Okay, so we may end up having more than one, and this will be characteristics. I think that's correct. Define, and then we're going to put in another, it doesn't really matter, these are just randomized and made up. In a previous, one second, can't talk and type at the same time. In a previous stream that I did on this, one of the previous videos, I spoke at length, I remember doing that about setting up, like there's different UUIDs that are like standard. So we can just make up our own because we're just playing around with this, but there are standardized ones that are available, I think, on like the Bluetooth website, the official thing. There's like a whole list of them. Different companies will have different UUIDs that are particular to them. And then there's also like special ones for like audio and things like that. I think the reasoning behind it is because if you have an app that wants to like stream music to an audio device that you didn't build, there's well-known characteristics that like all the manufacturers will use, so that you can say, okay, I'm going to hit up the audio characteristic, and then I know I can stream audio directly to that this particular value. In our case, we'll just have these random UUIDs, but like I said, industry will have like specific ones for specific tasks and stuff. So there will be a UUID out there for audio. I think there's like washing machines and all sorts of like weird stuff on the official listings and that. We won't go through that today. Okay, so we've got our characteristics and our service done. So I think we got to set up our, so here we've got server and advertisement data. I think I'm going to skip over these for now. It's on a different screen. I'll come back up to them if it turns out that we do need them. I do have a dog barking in the background. I hope it's not too distracting. So in the setup, we are going to do some setup. So we want to set up our Bluetooth. So let's do that. So let's set up our Bluetooth services. Let's give ourselves an output here so that we can actually read something that's coming from the device. So we go print and we say setting up Bluetooth services. Cool. Remember to add the semicolon on the end there. And then what we can do is we can also set a name. So we'll initialize it here and we'll call it, I don't know, my ESP32. And what this will do is when it's doing a broadcast or just saying like, hey, I'm looking for a partner basically, any apps or other services listening for it will see my ESP32. So you know when you're like, when you're going to go connect a Bluetooth device like a keyboard or a mouse to your computer and it says like, oh, this is a Logitech thing, like it tells you what it discovered, that'll be this is the name that will show up. So you set that to whatever your device is. So yeah, my ESP32 is fine. So let's create, I think we may need to create a server. Let me just check this code real quick. If we're using it elsewhere. Yeah, we need it so we can create our services. Okay, so what we need to do is, yeah, we need to get back up so we can do some advertising. And okay, so let's just throw this up the top here. So we go BLE advertisement data. Did I spell that advertisement? Code completion in this is not that great. B server for Bluetooth server. So that's where we got that set up. Okay, so if I just run this quickly, just do a compile and just see if I've got any errors in here. This could be spelled incorrectly. I think we should be okay. It's good to do this occasionally as we go along, right? Takes a bit longer now because we've included these dependencies, Bluetooth stuff. Okay, it seems to be fine. Awesome. Okay, so let's get back to our setup code. Yeah, cool. So let's go B server. This is where we're going to do the actual initialization. So we don't have it initialized up here. We're going to do that now because we will reference this, I think, in other parts of the code. We'll see. We might be able to get away with just initializing it in here. We'll see. Because the code that I'm copying from is reusing this, but we may not need that for our own applications. So we've got BLE device. We say create server. There we go. We've got some code completion there. Create server. B server, and it looks like there's a set callbacks thing. Let's see if we need this. Yeah, oh yeah, of course. Let's do that. So this will give us some readouts when a connection has happened and when things have disconnected. So I'll go a little bit more into an explanation of what that actually means in a second. So we say set callbacks new, and this will call a function that we haven't created yet. Or it's a class, sorry, you pass through. Okay. So this will be a class that we need to create. So if we build this, we will should get an error saying that this does not exist. Here we go. So we've got unexpected type specifier before server connection callbacks. Cool. So what we can do is we'll create this, and then what I'll do is I'll compile it, we'll run it on the device, and then we'll see it load up. So we've actually got something happening, right? Something interesting. So let's do that. So down here, let's throw it at the bottom of this file. I could create another file, but we're just gonna throw it at the bottom here. Server connection callbacks. Okay. This is public, and this is a subclass of BLE server callbacks. And I believe this is likely part of the, BLE server.h. Yeah. And this is going to expect some functions. So I think one of them is on connect. Yeah. On connect, go BLE server. So we got one here. And the other one is void on disconnect. This is always good to have set up. I don't think this is a requirement to set these up, these callbacks, but we do it so that we can get some feedback as to what's actually happening with our Bluetooth device. You can probably remove it if, once you've gone through all the debugging and stuff. Okay, so what we'll do is we'll go serial print, and then in here we'll just say connected. So this will run when our phone connects to it, and then we're going to do the same down here. We'll just say disconnected. Disconnected. Yeah, it's usually this time in the evening. Actually, she starts barking at everything that wants to walk past the front yard. Okay, so other stuff you can do in here too. So like if you're, this is what I would do. So if you have like code that runs on this that's really, really heavy and it's like running in this loop, and it's always like transmitting, you want to transmit updates, for example, like motion changes or like temperature or something like that. What you want to do is maybe check in here and set like a Boolean, like is connected or is not connected. And then that way in this loop, you can say if is connected, send the information. If it's not, don't do anything. Because otherwise you're like using up battery and stuff, right? And then you can make it say sleep. Maybe, every 10 seconds, check to see if there's, advertises Bluetooth information, or you can just have it so that advertises it on startup for like 2 minutes until your phone connect. There's lots of different things you can do to save your battery power. Especially like you might want to take readings from this, like in your garden, right? Like you want to hook up a battery, put it in a box, and then leave it there for a couple of months, and only collect information periodically, and then once a month when you go stand next to it with your phone, you can do the transfer. That way, you can save battery and stuff doing it that way. So that's what you would use the on connect and on disconnect for. That's what I've used for in the past. So let's get this uploaded. What do we got here? Oh. What have I done? What we got? Expected type, server connection. Have I done something weird here? Sorry, give me 1 second. I may need to throw this up higher. Is that how that works? Yeah, I don't have music this time. I didn't set it up. Sorry about that. It's just, yeah. Okay, so that was the issue. So yeah, it's like a Swift playground. Yeah, you got to have them in correct order. Okay, so while that's going, so we're just writing it to the device. Again, this takes longer too because there's a lot more stuff to write. Move up. What are we doing? What am I doing? What do you mean by that? What am I doing wrong here? Move up. Move what up? Can we scroll up? Oh, move my code up. Yeah, sorry. I've got it. Oh, another app that's very useful. Let me open this up. Is this Bluetooth inspector. I think this one's free, and I think it's available in the App Store. So this will help with debugging as well when you don't have an app ready to go. Like you just grab an app that can search for Bluetooth devices in the area. So we just got it's been uploaded. I'm going to hit start scan, and I've got my, all the stuff that's around me at the moment. Let's see if we can find. See if we can find this device pop up. It could be a number of these. Sometimes the setting like the Bluetooth name doesn't work. So we can find it in the unknown section. Let's do another restart and see what happens here. Yeah, it won't show because we haven't got advertising set up yet. We need to turn on advertising. So that's the problem. Okay, so yeah, we're not going to get there just yet. So advertising, you got to tell it. So we've got the Bluetooth stuff set up, including the service. The next step is to set up advertising so that when this thing boots, it's actually broadcasting information about itself, including its characteristics and things. Okay, so what we need to do. Okay, so let's start with. So up here we've already put the advertisement data here. So what we're going to do is. Yeah, where are we? Oh, she's loud. Might have to do something about that if it's a bit too annoying. Advertisement data. Set. Oh, this is the wrong one. Hang on, sorry guys, 1 second. So we've got. So we've got setup done. Yeah, so let's avoid the characteristics and stuff for now. Let's just go with starting advertising, BLE device, get advertising. That's it. We got BLE advertising called P advertising, BLE device, and get advertising. Excellent. So we've set up a way to advertise the device. So we just need to go ahead and add some services and stuff to it. So we've got P advertising, add service UID. And then what we're going to do is we're going to pass through this LED service that we created. Cool. And then we're gonna go p advertising. So these are some boilerplate stuff that I don't quite understand. So we've got also set scan response true. Set minimum preferred. I did read about these when I went through it, when I first went through and built this code. I cannot remember the reasoning behind these values. And for some reason, we might be able to delete these and it'll still work, but I'm just gonna put these in for now so we've got like less issues. So yeah, you notice this is set to this value and then we're setting it, changing it and setting it again. I remember there was some comments and some code that I borrowed this from a while, like ages ago. It was like there was a reason for it. It had some comments here like we gotta do this for some reason. It might not be a thing anymore, but it's still in this other code. So, and I have to copy from code that I know works because I haven't done this often enough. I'm an iOS developer, right? I haven't done this often enough for it to be be muscle memory. And then we just say start advertising. Okay, so we're advertising these this service value, and at some point we're going to start advertising. We're going to do like set up the characteristics that are attached to these services. The service is just going to be empty. It's not going to have anything on there. So I think this is pretty much what we need to do. Let's do another compile and send it to the device and wait and see how this goes. It's that start advertising that I think will get us there in our other app. So let me bring that over. It's Bluetooth inspector. So this will be like, this is all like stuff that's probably in my house and also the neighbors and things, right? There's a lot fewer here than I would have expected. I mean, the last place I lived in, the apartment I lived in, had like, there'd be hundreds of items in here. So we're at 40%. 1 second. $55. Yeah, programming streams where you're doing like all this compilation, very boring. I don't know how to make it more entertaining. Maybe we can do stuff during compilation. I've got to come up with something. It's too dry otherwise. It's like, let's just skip through the video and find all the juicy bits, the bits that I need to finish my project and not actually sit there and watch it. Okay, so this should be running. I'm just gonna hit reset anyway. And then I'll start scanning again. Let's see if something pops up here. So my ESP32, I don't know if you can see that. Where'd it go? Oh no, come on, it's like frozen now. All right, I'm gonna close this down. Let's reopen it. I haven't got time to wait for all that. Let's start scanning. So we should have my ESP32 there. This jumps around a bit. It's not the best software. Like you select something and it just disappears. If I interrogate this service, we get, it says no services known. So, oh, Apple Watch got interrogated there. So hang on a second. Okay, so we've connected to my watch apparently. That's pretty cool. So here we're doing a little load on these services. This is a UUID with 0 characteristics. So if we go back up here, we can see that these UUIDs match. So you can see how we've got CEs, like, okay, 5EB. This one here's got the 5EB. Okay, so this is correct. Our service was advertised but not yet discovered. So there's nothing, we haven't done anything else with it. We're advertising this service and there's 0 characteristics there. So that'll be the next step. So yeah, this code works. So let's just go through what we've done so far. As a little bit of a recap. If we have, do we have this here? What do we set it to? I think it should be. Oh, I haven't set the baud rate at the here. Do I want to do that? Sure. Let's just set to that. And then, yeah, that's fine. Okay, so while it's compiling and uploading again, let's talk about this real quick. So this code so far is pretty short, right? So all we've done is we've imported these dependencies for Bluetooth. We have created a service UUID. This is so it can be found by other devices. It's just an ID that we can use. It can be anything. We've created a characteristic, which we haven't used yet. And the characteristic will control that exact thing. Excuse me. So we have an LED characteristic. LED service could have a number of characteristics categorized underneath it. We've got the advertisement data set up here. So this will be accessible from anywhere within this file since we've declared it at the top. And then we've got our server. So we'll skip over this for a second. In our setup method, so every sketch that you create is going to have a setup and a loop for these microcontrollers. So in here we're printing out setting up Bluetooth services. We have given our device a name, so that's what we can do here. We can pass through nothing as well. We can pass through an ID. It can be whatever we like. We create a server and we set a callback to this class. So the callbacks this is all code that that BLE server callbacks expects. So this stuff is called automatically for us, right? We don't need to call on connect or on disconnect because we're passing it through this set callback. So this is all handled for us, right? We just need to provide it a class of some type that implements these. So much like in iOS development, this would be like a subclass of some type. And I guess I kind of think of it almost like a protocol as well, because these are the functions that we must implement, I suppose. I think we can get away with not having them, but then they just wouldn't, like nothing would happen. So like, whereas in iOS land, if you don't have a function for a protocol, it'll, the compiler will yell at you. In this case, I think we are okay not doing that. We could have a quick test. Yeah, I think it should be fine. Yeah, so the upside to it breaking in iOS on Xcode and that is that it tells you what's missing. You can say, let's fill in all the blanks, and and Xcode will do that for you. Whereas in this case, you can pass through a class, but you don't know, like it doesn't tell you. You're gonna have to read documentation, okay, for these libraries in order to know that this is what it's called and what you need to have implemented. Unfortunately. So anyway, continuing on, then what we've done here is we've set up the advertising system here. So this will advertise this device. Basically, it's turning on the Bluetooth and just putting out there. I think it's just polling repeatedly saying I'm here, I'm here, I'm here, and these are my services. And at the moment, we've just got the one. Okay, so let's close that down and let's keep moving. I don't think there's any questions. We've got like one person watching, so it should be all right. Next, we are going to, so we've started the Bluetooth advertising. Next step is we need to set up the characteristics for this device. And in our case, we've only got the one. And characteristics can have a few things going for them. So you can have, you can set them up to be, you can declare them as like writable or readable only, or both. And there's also like notification as well, like it can notify a system that's listening to it. So in order to do our LED, let's go with, yeah, let's do it this way. Oh, okay. So the documentation, I'm just using. So what I've got here is I've got another project that I am pulling information from, like where I've done all this before. So that's where I'm getting it from. This project here is based on tons of research, watching lots of other videos, and reading documentation from, you know, like these libraries basically. So you can just search them up. There's other tutorials and stuff online where I've sort of like pulled all this information to get this working for us, for iOS development. You know, to talk back and forth between an app, and this is the best, yeah, the best way I can make it work. Yeah, so it's just off screen. I also have an app off screen as well that I've been using this. So when we get to that part of it, I'll be pulling code from an app that I've been working on as well. Yeah, much quicker than me just like trial and erroring the whole thing. Okay, so yeah, let's set up the services just in between here. Set up the characteristics, sorry. So we go BLE characteristics, we've got, let's call it LED characteristic. And then I guess we need to start with our service, which will be our, oh, that's a good point actually. Let's start with the service first. So we have a server and we need the service before we can get our characteristics. Sorry about that. So we got our service. B server, which is this here. So we set it up based on our server. Create service. Create. We need to go with our LED service. Awesome. Should be all right. And then for the characteristic, it's based on our LED service. Create characteristic. What we'll do is this will go down on multiple lines. So the first thing we pass through here in this, I guess, function is our UUID. And once again, this is another one of those things that you just have to know. So this property right is just, it's in the documentation. Like it doesn't, there's different values you can pass here. Like I said, you can do property write, property read. In our case, we want to do write because we're going to be sending information to this device. I think the reasoning behind this is for like security measures and stuff, right? So sometimes you don't want people to be able to write to a device, just be able to read the information coming through. So I think that's kind of it. Let's do a quick compile, see how we go with that. Yeah, seems to be fine. Excellent. So the last thing we need to do is have a way to respond to when information is sent to the device. So at the moment, we've got like our characteristic and stuff set up. This is all well and good for, you know, I guess advertising and putting information out there where anyone can listen to it and get it. In this case, we need a way to respond to that. We haven't got anything happening, right? So like as soon as something is detected being written to the device, like there's no code here that acts on that. So what we need to do is create some code that does that. And then what we'll do once we've done that is place it down here. It'll come in here. It's very similar to setting up these callbacks here. So well, we can finish that up. Let's do that first. And then we'll come up with a class. So if we say LED characteristic, LED characteristic, and then we say set callbacks, and this is, we initialize a new class here and we say LED callbacks. That's what it's going to be called. Okay, so now we're going to pass through a new class called LED callbacks, which is going to be a subclass again. So let's go class LED callbacks, public BLE characteristic callbacks. So if we go to definition, do I do that incorrect? Huh. Oh, they're gone now. None of them are working now. Interesting. I wonder if that's a compile issue. Doesn't matter. So on here we go on write. So before we had on connect, on disconnect, here we have on write. So anytime a write is detected, this function will run. Characteristic. I find it difficult to type that out. Let's go with. Okay, this is the point where you're kind of like, all right, what are we going to do as far as like, what's the data type going to be? What do we expect? For turning a light on and off, it's just going to be like a Boolean, right? So we can say yes or no. And I think it's probably like too simple for this example. We'll start with that, and then we'll make it a little bit more complicated later if we have time. Actually, let's just go with, maybe we can go with string value. Let's see what we get out of this. What we can do is we can always print whatever's coming in from in this function, whatever we get, and then we can do something with that. So if it's not correct, we'll change it, either at this end or at the iOS end. Great. So here we go. So this is basically our value that comes back, and we can do something with this. So I'd say we print it out. And just see what we get. Yeah. So sometimes, like, what will come back, from what I remember, what comes in is just like, it won't be readable for us. We have to like convert it, but let's just see how we go. We might be lucky with it. Okay, so what we've got set up here is, actually let's do a compile. So we got LED callbacks is run, and this on write, when that happens, this gets executed. What have we got? What have I done wrong here? Oh, I think it's because we're trying to print. Oh no, okay, here we go. This is the same code though. Should be fine. Ah, hang on. I am doing something else further back. I'm sure of it. Doesn't look like it. Interesting. Oh, it might be in another file. We can go with this. We can see. Let's just try it. Let's just try it. See what happens. Let's send that to the device. And I think this other Bluetooth inspector software I've got can write to a device. See how we go with that. But it might be time to jump over to Xcode. And this should be 96, yeah. Okay. So we just gotta wait a couple of seconds. Not much I can do while this is happening. Gosh, taking forever. Usually I like recap, but we kind of just did it, so. We'll just clean that up just a little bit. Okay, here we go. Let's do a little scan and see what we come up with. Hopefully we got our characteristic there. Oh, nothing's showing up. Okay, this app probably needs to restart again. Come on. Just nothing showing up this time. That's not cool. Okay, let's try again. Here we go. My ESP32, let's click on it. Come on, stop jumping around. Oh, come on. Interrogate. Excellent. So what have we got here? No services found, we're just waiting. Come on, characteristics. Okay. Let me just check if compilation much faster in platform IO. Oh, is it? Might have to try that. I did use it for a little bit on a different project, and I found it was really it's not as simple as this one. There's a lot going on. It's not working at all. This is wild because like I'm trying to all right. So if we go to, so we've started advertising our like everything. It doesn't seem to be working. So we've got our service. So just gonna double check this. Let's go create server. We have our characteristics set up for right. And then should be it. I've worked it out. So where are we? Where are we? Where are we? We have. This will be it. Oh, automatically want to save. All right. Okay, so while we're waiting for this to compile, let's get started on our iOS side of things. Because what we want to do is like put a button and stuff in here, right? So let's start with, let's go with that. Oh, well, actually, we can reuse all this. Let's chuck this in here in the label. So this is just a new project. Okay, so all I've done is like create a new SwiftUI project, and this is like what it comes with. So in here, inside the button, we will run some code. I think what we can do is instead of, do we want to create a, I want to see if I can get away with putting everything in one view. So we're not even gonna have like a view model, hopefully. And then down here, what we want to do is create a function which is like toggle LED. Okay, so we'll throw that in there. We'll just say toggle LED. And then everything else is going to be behind the scenes. Hello world, let's just say toggle LED. Let's do, what else we got? We got light, sun. Sun should work. Star. Oh, sun, min. Let's go max. Cool. There we go. And we'll just add some padding around it. All right, looks like our thing has been updated here. So let's just see where it is. We got ESP32. Let's interrogate that. See what we get. One characteristic, excellent. So we've got, our characteristic is CB9, and I think, yeah, we got CB9 there. All right, let me bring this across so you can see it. Okay, so we've got ESP32 selected, and then I just clicked on the characteristic, and this is what we got. So I think, yeah, so for sending, for writing, so we've got write up here, and we've got read. You might not be able to see that too well, it's really small font. This feature requires Pro. I don't have the Pro version, so I can't like write to it. That would be helpful. I wonder if, let's see how much this thing costs. $6. I'm tempted, because it's cheap enough, right? But the fact that like the UI jumps around and stuff like that, I'm just kind of like, oh, I don't know if maybe there's a better version. I'll pay $20 for an app like this that has like a stable UI. We probably don't need to worry about that just now. Because what we can do is we have an app that's going to do this anyway. It's going to write information. But it looks like we have string, number, and hex values we can send. I'm going to try with the string, and I'm going to send true or false with the string. Like I said, we could do a number 0 or 1 or something like that. But what I want to do is be able to extract the actual data so that anyone watching this is able to do that as well. So not everyone's going to have like a toggle that comes through, is what I'm saying. They might want to be able to send other information, like a number of values. Maybe they want to set the color of the LED, and they want to send through like, you know, a bunch of different RGB values. So let's just keep that off to the side. But the good news is it works. So if we go back a couple of pages, so before we had 0 characteristics here and just like nothing, right? It said one service with nothing. We had little warnings in that. But you click on this and it takes you straight into that characteristic. So everything's working, right? So our device is like advertising and everything. And it's only just like a couple of lines of code, which is really, really cool. Like this is, I think this is about all we need. For the loop, we can, you know, do stuff later, but it's like we don't even need it at this point because it's always listening. for information coming through on this callback here. This is pretty much the main part of the show, like where we're going to be running this code. So I think for now, I'd say that's a success. We can probably move this off to the side and just continue on with our app. We might not even need the preview open. It's just a button, right? So like that's taking up space. I don't know. Let's see how we go with that. So up here, we are going to import CoreBluetooth. This is one of those things that doesn't have a lot of documentation. Like Apple, you know, it's just as much as every other Apple framework. But when it comes to like tutorials and stuff on Bluetooth, there's like no one's done it. It's a couple of like, you have to kind of like pick through all different articles in order to piece them all together to make the one thing that you need. There's no like full guides like this that I know of anyway. So we've got the toggle LED, we've got our button, CoreBluetooth imported. So what we need to do is, it's a little bit more code here. So we've got things called a peripheral manager. We may end up needing multiple files. And then like a Bluetooth service. So this other project that I'm going to be pulling this from has a file called Bluetooth service and one called peripheral manager. And then obviously the view and stuff. So let's start with our... Yeah, there's a couple of properties here that I would like to keep separate, and it would make it easier to drop it straight into your... Because if I do all the code in this view, you're not going to be able to just drop it into your app. So I've changed my mind. I'll make it so that if you get hands on the code, you can just grab the entire class. So let's call this a Bluetooth service. This has to be an NS object because, you know, Apple haven't. We can make this an observed, you know, use the newer syntax and stuff. Let's just go with observable object for now. We can clean that up after, I think. We'll just go. I mean, that probably works, right? Observable. I change my mind a lot during these streams, so just have to get used to that. So because this is a like a Bluetooth service, and it's something that you might want to keep alive while you use the switching between different screens of your app, we'll make this a singleton. You can also make this like an environment object. But for people not using SwiftUI and want to use this in their UIKit project, we'll keep it as a singleton. Sorry, it's shared. Looking at the wrong thing here. Bluetooth service, cool. And then we need a private var, which will be the central manager. So this will be CoreBluetooth central. You can already tell I'm like much more comfortable in this IDE than the other one. So let's go with our let's call it our peripheral, because that's what they are. That's what Apple calls them. Peripheral. So this will be our ESP32 device. We'll set it to optional because we don't have one yet. We need to search for it. There's some other stuff we can do here too, like set the peripheral status, whether it's connected or disconnected. I don't think we need to worry about that for this task. See how we go. Let's keep going. So obviously we'll have I'll go with a private initializer. The reason why I might mark these private as well is because like when we're doing a singleton, it stops anyone from not using the shared, Bluetooth service.shared. Because if you mark it as private, then they can't initialize it and they have to figure out another way to do it, which is good. You can always remove that private if you don't want to use that. Okay, so we've got central manager, which we need to set up, which is CB central manager, and we need a delegate, which will be self. We're going to set up on a queue of any sort. In this case, we'll do a print. Oh, you know what? Since it's been dropped into someone's project, possibly. Let's do all this properly. Let's throw it up here. I can split this into another file in a minute. Let's go with OS log. There we go. And this is expecting a delegate which we don't have set up yet. So what I'll do is we'll do an extension. Yeah, let's do an extension down here so we can quiet that issue. So we got Bluetooth service, and this will be the CB Central Manager delegate. There's going to be more code on the iOS side than there is on the Arduino ESP32 side. And like I said earlier, this actually tells you like what you've got missing, which is awesome. So Central Manager did update state. Okay. Let's just put the boilerplate code in here. State is equal to powered on. So this is for the Bluetooth stuff, right? And then we'll just go with an OS log, and we'll just say CB Manager is powered on. So once this turns on, because it does take some time, like time as in, you know, less than a second or something, it still takes time to boot up. So what you want to do is you want to get this, like, you need to know when the Bluetooth's ready to go, basically. And then once that comes through, it says it's powered on, then we can start searching for peripherals. We need to do a scan of the area. So what we can put through in here is scan for peripherals. And what we'll do is we'll throw that, we can put that down here. This isn't to be confused with the scan for peripherals function that we'll have to call in a second. So you saw before when I was typing this out, scan for, oh, it's gone now, don't worry about it. Okay, so in here we'll have to initiate our scan. So let's do OS log again, and we'll say scanning. Hello, Sebastian. Scanning for peripherals. Cool, Central Manager. Okay, so there's the new one here, scan for peripherals with services. So I think in this code that I'm using, I created some helpers for this. Yeah, I did. So here's, I'll just drop this in real quick to show. So we've got like an extension on CB Central Manager, which is like, I did it so that we can just, it's cleaner at the call site, but it doesn't really matter. And this will just create a CBUID string with the, because what I'm using in my other project, instead of just like declaring the UUIDs for the characteristics and services, I've put them into like an enum so that I can just like do a dot service. Okay, so, but let's just pass through the CoreBluetooth UUID, which, and this service string here will be, we've got to pull this from our file here. So what we've got here, we've got our LED service. So let's grab that. Now, hard coding these isn't like great, because if you were to change them, for example, or another, it's unlikely another system will use it because these are pretty unique. But what you could do, how else would you do this? You can search for services. I believe you can search for all services, because the way that Bluetooth Inspector app works is it just doesn't care, right? It's just searching for everything. And that's why everything kind of shows up in this panel, right? It's not specific about it. But when you're like building an app that you need to talk to a specific device, and like all you care about is your ESP32, it's good to throw in like your UUIDs so that that's the one that comes up. So your callbacks in your app, when it finds a device with that service, will only get triggered when that particular ID is found. Does that make sense? Like you don't want to trigger the callback every single time you find a device, otherwise you end up with like a large array of them, like in this app that keeps crashing. Probably because there's so many devices. So yeah, if you want to be really specific, that's good. You can also create an app like this Bluetooth inspector by following this guide, this video, and just not passing anything through. You just leave this empty. I believe you just leave this empty. Let's see if there's another central manager scan for peripherals. Scans for peripherals are advertising services. So if we were to pass through something here, let's see what the documentation says. Okay, an array of CBU UID objects that the app is interested in. Each CBU UID object options, a dictionary of options for customizing the scan for available options. So yeah, you can pass through options as well. You can provide an array of these UUID objects. When you do, the central manager returns only peripherals that advertise the services you specify. If the UUID's parameter is nil, this method returns all discovered peripherals, regardless of their supported services. So yeah, it's recommended that we put something in here so that only our device gets returned. But like I said, if you remove it, you can have some fun with scanning the Bluetooth devices around your house, which could be pretty cool. So that's that. That's pretty much all we need from what I can see here. That's pretty much it. Let me just jump back to just double check. Yeah, so what you would do in here for future reference is perhaps you want to call something else too, like instead of just like printing this to the console, you could say like in the UI, maybe we can put, you know what, let's do it. Ooh, peripheral state. Let's say scanning disconnected, connected, error maybe? Maybe we can have an error? I don't know what ones we're gonna need. Let's go peripheral state and set this to disconnected or idle, I think. Yeah, disconnected is good. So what I'll do is down here inside the scan for peripherals function, what we'll do is we'll set the peripheral state to scanning, and then inside our let's go with a VStack here. Let's put in a circle. Let's do a refresh on this content view. I just want to see what this looks like. First up, I think it would be big. What's going on? Failed to build the scheme. What have I done? Oh, okay, yeah. So we need to delete that. We're not using that anymore. Let's do a refresh. Okay, so there's our circle. Great. Let's set its fill color based on our state. So what I love to do with enums is pass through, like have properties on these things, right? So I can hide away all this stuff inside the enum, which is awesome. So so for color, we do a whole bunch of switches. So we switch on self, and then we've got scanning disconnected. So scanning might be, I don't know, blue. Disconnected could be gray. Is it gray? Connected could be green, and error will be red. Does anyone know if red for error and all that is the same in every country? Because that's something I haven't even thought about until just now. Right? I'm sure somewhere in the world green is the bad color, right? Anyway, so we've got our circle, and then what we can do is we can go say fill, and we can say the fill is We need to have our Bluetooth service up here as well. So let's do that. Peripheral state. Oh, whoops. We're going to go var. And then if we do a refresh of this, so we've got gray. So we disconnected. So we've got a gray color coming through. So how cool is that, right? So we'll set let's set a frame. Say max height is like, I don't know, 50 maybe. Let's go 100. Okay. And for the button style, set it bordered so you can see it a little bit better. Okay, so there's our connection status for our device, and then we've got our toggle LED button. So what we could do really if we go back over to the Arduino IDE, we can also set this characteristic to be read as well, not just write. And what would be awesome is if we could, like, once the status of the LED is set, the app can then check the device to see whether it's on or off as well. So then that way we can update the visuals of this button. We can say like LED is on, and you tap it and then it goes, hey, LED is off. And then we can even have like a little animation, like a little circle thing animating a little progress indicator that will just like display whenever we're doing like communication between the two devices. I don't know if anyone's used like the automation stuff in the Home app. It's similar to that. Like if you tap on a light to turn it on or off, it does take a couple of seconds for that the information to be sent. It's the same as like if you're asking Siri or something like that to do something for you. It's going to take time. So here we go. Okay, we got all that done. So we got our initializer set up. It's running. It's doing this whole scan. If I don't know if this will work with the sim. So if I restart this, I'm gonna get anything here. I don't think so. I think I need to run this on the device to get the testing working. Because otherwise this should have changed, because it would have started scanning, and that's what we need, right? As soon as it starts scanning, it should have showed a blue color, and it's not doing that. So I don't think this code is getting run at all. Let's say else here, and we'll say CPU manager is powered off. Let's see what happens. I don't even think it hits breakpoints in these. Hit save. We're gonna go refresh here. Come on. Here we go. And tell me this stuff doesn't run on the previews. Okay, it does work. These logs do not. Yeah, so the OS log doesn't work in the previews. Okay, that's something for you to remember. That's so funny. I've been trying to like do this to keep it like legit and clean, so that you can just drop this into your app and it's like, oh, it doesn't even work. It's print statements. Okay, that's fine. Whatever. Okay, so what we'll do is we'll test this on a device in a couple of minutes. So we've got scanning for peripherals happening. We haven't got like a callback for when it finds a peripheral. So that's the next step. So all we've done so far is we've set up the central manager. It's turning on the Bluetooth, right? And then we're going to scan for these peripherals, and it starts scanning here. So let's move this out of the way. Let's pop that down there like that. But what we need to do for the central manager delegate is we need to create a function for when it detects our device. So that is underneath did discover. I'm pretty sure I'm going over some content from the last videos as well. So if you're watching this and you're just like, oh, you already went through and did all this Bluetooth stuff earlier on. Yeah, I know, I'm sorry. It was such a long time ago. I apologize for that, but I think it's important. Just skip ahead if you don't like it. Okay. So things we can do here as well. We can also check the strength of the signal. So we can say we only want to connect to the device if it has a service with this UUID. And in here we can check the strength. We can say if the strength is, which is this RSSI value. That's in case like it's in another room, or you think it's going to be the connection is going to be a little bit iffy, and you need to have a strong connection to turn on a light bulb or something like that. But in our case, I don't think we really care about it. So I'm just going to go with print this time because we know that works in the previews, and we'll say discovered percentage D, and we'll go string describing peripheral name and RSSI in value. So let's just go with this, see what we get. I don't think we're gonna get anything printed though. Sorry, I'm scrolling up or down all over the place. Let's clear this out. There's nothing that's getting printed. We go scanning here. What's going on? Oh, so we're getting into the powered off. Yeah, that's why. Yeah, okay. Definitely can't test this on in the simulator by the looks of it. That's all right. Okay. Let's just throw that in a log as well then. Okay. So what we can do now is we want to check to see whether the current peripheral is nil. So if you've got like 10 of these on your desk, probably don't want to like try and connect to all of them if they've all got the same UUIDs and stuff. So what we'll do is we'll just say if peripheral is nil, we can say, well, we found our peripheral. So what we can do is actually where we need to, I think it's called LED peripheral, isn't it? We got peripheral. We need to change to LED peripheral so it's got a different name. So if LED peripheral equals nil, what we need to do is we'll set LED peripheral equals peripheral. Okay, so this is the one that's discovered, which is what gets passed through here in the did discover, central manager did discover function. This is a delegate method, so this is something that is given to us by CB central manager delegate. So this is the one you need to implement if you want to get these connections and stuff working. So the next step is, now that we've got this, we can say peripheral state. Oh, we need a connecting state too, don't we? So let's just add that in there too. I believe this should be like a, we'll just make it like a yellow. There we go. So connecting, we can also use text, doesn't matter. And then we need to call connect on this value. So we on this peripheral. So what we can do is we can say central manager. We can say central. I think we can go over just central. And we can say connect to peripheral. Okay. Yes. So okay. So something I want to bring up now because I just realized. I believe it's this CB peripheral that you need to have like a constant, not the peripheral. Sorry, the where is it? The central manager. It's something. There is a. I'll point it out when I find it. I think, but I just want to mention it now while it just popped in my head. There, I think it's the central manager that you need to keep a reference to. Like you can't just initialize it when you need it, or the peripherals you need to keep a reference to. Yeah. Because yeah, it's the peripherals you need to keep a reference to. Because if you don't, like if we don't have this set LED peripheral, and we just said like this wasn't a thing, right? Let's say we didn't do that, and we just said let's just connect to this peripheral that's passed through. It disappears for some reason. Like it doesn't work, right? So you need to keep a reference to it, and then so we can say connecting LED peripheral. So we can do something like this, okay? Yeah, there's something about it like where it'll fail to connect, or it won't hold on to. Since we got a reference, we should be fine. But yeah, there's something about it. I was having troubleshooting it when I was originally working on this code. Yeah, I just figured I could pass this around from function to function as I needed to. It's not the case. You have to hold on to it. It will get deallocated otherwise. So we've got did discover. Great. We found what we're looking for. Now we have to have a callback for when we connect. So we just go did connect. And then we may as well do did fail to connect as well. I don't really care about the error too much, but let's just do a OS log. Let's just do a print. We'll do a print. And then we'll just pass through error. It's funny how it failed, but the error could be nil. Okay, so up here, now that it's connected, we can say peripheral state equals connected. And then this is where we can start doing a couple of things with it. So what we want to do is set the peripheral has a delegate as well, confusingly. And then we have to discover the services on the peripheral. We already know what they are. So this is where the Bluetooth stuff gets a little confusing with iOS development. So we go scan for peripherals with services. So we will pick up all the peripherals with the service. And then now we have to like interrogate, which is what was on the other app that we saw. We have to interrogate the peripheral for what services it has and the characteristics on its services. So in order to do that, we say, what we got? Peripheral. This is where we need to add the peripheral manager, I believe. Bluetooth service and peripheral manager. So what I'll do is we can start working on that in a second. We'll come back to it because I don't want to get things to be too confusing. So what we'll do is I'll just comment that out for now. We just want to say discover services here, and we just say CBUID, and we pass through our string, which is this for our service. Okay. And then did disconnect peripheral, we'll do the same here. We'll just say print disconnected peripheral. So this will pop up if I press the reset button on the device. get disconnected. We can test that out. Okay, so we need to do the delegate because everything else gets passed off onto the peripheral itself. So the Bluetooth service stuff, the discovery and all that is all within the Bluetooth service file. The rest of the work is done inside the peripheral delegate. Okay, so let's just go ahead with that. Cannot assign value of type to any. Oh, yeah, because I uncommented the thing. Okay. Yeah, this is local. It's been a while since I've done a stream. And usually they're planned out a lot better. So what I'll do is like I'll sit down a bit beforehand and try and plan things out. I already knew this, even with planning, was going to be all over the place. Where are we at as far as time goes? We're at an hour and a half. We're doing pretty good though. Usually the streams go for about 2 hours or so. I feel like we're going to hit about 2 hours and then we'll be done. Okay, so for the peripheral manager, so what we're going to do is, should we do another singleton for this? If we do another singleton, then we can talk to it directly from anywhere in the app and bypass the Bluetooth service itself. I'm thinking. Yeah, let's go for it. Let's do it that way. I think that'll be easy. Yeah. Peripheral manager. NS object. And again, this will be observable. Static let shared. Peripheral manager. And then let's do the private override init. And in here, we're just going to say super init. Okay, because we're not setting anything up. Oh, we don't need that either. That's for a different thing. So all we need is our peripheral. If you have multiple devices, you can put them here as well, but we're dealing with just one, so. Just checking here. Just want to read ahead just a little bit to make sure I got this right. So what we got, did right value. Yeah, it looks like you get callbacks when you run a value. So like it was successfully sent to the device, which is good. We need to discover the services and we need to, yeah, so let's just do away with this for a second. We might be able to get away with not having this whole thing, but hang on, give me 1 second. Yeah, so what we need also is to pass through this. So we need the CB peripheral delegate, and then what we can do up here is we can say our delegate is going to be our peripheral manager shared. That is the delegate. So any devices we discover that has this service, has a service with this UUID on it, we'll call the functions on peripheral manager.shared, which is this file. So we're going to start implementing these delegate methods here. So the first one is did discover services. Okay, so this is kind of like the same as did discover peripherals for our Bluetooth service. So we do a scan, we find our peripherals, and we get a, like I guess the delegate method will trigger, and will give us our peripherals that we found. We're doing the same thing for services. So we grab the peripherals, we loop through them all. We're not looping at this point because we only have one we really care about, but you can get, like in here, you can have, this can get called multiple times. See, only one peripheral comes through. This can be called over and over and over and over again for every single peripheral that it finds, and you run code for that. And then for every peripheral you find, you need to discover the services. And this is what's going to get triggered for that. Of course, we could have put the peripheral delegate on the Bluetooth service as well, but keeping it separate kind of feels like it makes sense to me. So if we discover services, the services that come through on a peripheral are an array. Even though we've only got one on our device, we've only set up one. So you can say for service in peripheral services. Now here's the thing, you might think that you can do it up here when you get the peripheral come through. It did connect, and then you can be like, oh, okay, peripheral, let's go services. It's going to be empty. It's not going to be there, which is kind of annoying. Like you think that once, or even here when you discover it, it's like, oh, you're going to get some services. You'll be able to query this peripheral for services and characteristics and stuff. You can't do that. You have to do these scans. I hope in future that Apple kind of like just does it all in the background, but I wonder how, like whether it uses up too much battery or something to do that. Like, could you imagine doing it for every device that's found? Yeah, that could be expensive. So for each service, we've only got the one. So we should only find one here. We need to call discover characteristics. So we call discover services up here. We go scan for peripherals. We call on the peripheral, we call discover service. And then down here for every service, we need to discover characteristics. So again, on the peripheral, we say discover characteristics, and then we pass through our characteristics. Now, if we don't pass through a UUID, again, it's going to return all the characteristics it finds. When you're building your own devices, that's probably exactly what you want to do. You want to set this to like nil or nothing, right? You would, or empty or whatever it is, so that it just gets all the characteristics. For best practices and stuff, what we're going to do is we'll pass through our characteristic. And this will be based on the one that we have up here. This is our LED characteristic, so let's grab that. Okay, cool. Actually, you know what? I know I went through all that effort. Let's set it to nil, because I figured if someone's going to drop this in, it'll be annoying having to go through and out all that, or change them with your own UUIDs. So our CB service here that we're going to go with will be this service. So we just need to pass that through. So for service and peripheral services, we'll search all the characteristics on that service. So again, the way this works is you've got your peripheral, and then you have service, and then you have characteristic. Okay, so to see this in an example, this will be my ESP32 is the peripheral. Down here, our service is LED service, and on that service we have our LED characteristic. That's good enough. And in each device we could have RGB LED characteristic. We could have I don't know, blue LED characteristic. You could have all different in the LED service, right? We can name this whatever. This could be writable services if we wanted it, right? We can change it whatever we want. And then maybe there's like readable services, which is just so that we can get across like what these are, because I was confused about what characteristics and services were when I first started doing this sort of development. I was like, do these need to be like named anything in particular? Are they important in some way? It's like, no, this is just, it just seems to be like a way to categorize. There might be something hidden there that I don't know about, but this is how I interpret it. Readable surfaces might be accelerometer characteristic. And then we might have, oh look, I know this is spelled wrong, just leave me alone. And then we've got gyro, right? We've got gyro, we might have temperature and so on and so forth, right? So that's what we were doing this. Okay, so you need to search for your device, peripheral, and then you need to search for the services, like discover what services are on there, and then you need to interrogate the services to know what characteristics it has on there. You have to follow each of those steps. You can't just go straight to the root object and then just be like, oh, what's, yeah. Okay, so now that's clear. Hopefully I don't have to go there again. So discover characteristics, we're gonna set that to nil because we'll get all of them. And then once that is called, we get did discover characteristics. And then it comes through with our service, we get errors and that sort of stuff. So when we say did discover characteristic, we can say for. So notice how we don't have our characteristics aren't there, right? We have to get them off the service, which is silly, which is so silly. It doesn't just pass them through in service characteristics. If you had to try to get it up here, peripheral.services, and then, you know, 0 and then dot characteristics, it would be empty. Okay, it's going to be empty. So in service dot characteristics, just in case it's empty there, and then we go peripheral set notify value true for characteristic. All right, let's read the documentation on this. A Boolean value that indicates whether to receive notifications or indications whenever the characteristics value changes. True if you want to enable notifications or indications for the characteristics value. We've said the same thing twice. False if you don't. Okay, so discussion. When you enable notifications for the characteristics value, the peripheral calls the peripheral did update notification state for method of its delegate object to indicate if the action succeeded. If successful, the peripheral then calls the did update value. Method of its delegate object whenever the characteristic value changes. Because the peripheral chooses when it sends an update, your app should prepare to handle them as long as notifications or indications remain enabled. So this could be a little bit confusing. If we jump back to our code over here, there is something here somewhere where we say, we might not have it set up yet. So what you can do is there is a function here somewhere. I don't think we've done it yet, but anytime like a value changes, like when you set a value. So if I was to, let's say I'm sending the digit 1 on a Bluetooth to a particular characteristic. I'm just sending 1 over and over again. I can just set it up so that it's just set to that value, and then the iOS app has to read it. Like I have to specifically say, what's that value, and ask for it. Whereas what you can do is you can also set the device up to trigger a notify thing, in which case your iOS app we've set up to listen to notifications. So this isn't like the same notifications like push notifications or like local notifications in your app. It's a different thing altogether. There's like Bluetooth things. So this will send, like you can have it say, I want to trigger a notification, or if you just want to update the value silently, you can do that too. And then, you know, require that the iOS device asks for it periodically. The reason for this, why it's based on notifications and not, is because to notify, I think like it can be expensive as far as like power, like energy goes for Bluetooth, like to constantly be pushing and notifying. So what I did recently with the motion sensor on this, I found that because I was sending motion capture data back to the iOS app multiple, like 100 times a second, battery was draining really, really quickly. When what the smart thing would have been would be to maybe batch them. So send them every second rather than 100 times a second, and then send them all across at the one time. That may have been a smarter way of doing it, and it would have reduced like load on the battery and stuff. So this thing's, I don't know how, sorry, sidetrack. I've just been thinking, things like the Apple AirPods just are wildly crazy to me, because it's like they last, what, 20 hours or something like that, can stream audio, and the battery's only like 50 milliamp hours. And the batteries that I've been using are like 150, 200, and I don't get 20 hours out of them when I'm just sending like little bits of data. So they've got some really good power management going on there with whatever system they're using, especially audio. Like audios must be taxing. There's a lot of information that needs to be sent across. So yeah, it's pretty clever engineers, what they've got going on over there. Okay. So we've got our did discover characteristics for set up, and we've got set notify value true for characteristics. So this means we're just going to get like a notification when this value changes. And this is just basically for reading and stuff, I guess. What we want to do is when we get did update. So this is the other function that it was telling us about in here. So we can say did update value for characteristic, and this gets triggered whenever that value is updated. We don't care too much though, because we're not going to be reading the value for the LED. We are going to be just writing to it. So what we need to do is use a different one. So let's get rid of this one for now. Let's say did write value for characteristic. So this is where we can get a callback knowing whether us setting the LED to be on or off succeeded, like the device received that value. So what we can do is if let error, so we want to know if there is an error. Error writing to peripheral. Okay. In this case, we're just going to print out LED updated, LED toggled, maybe? Cool, LED toggled, let's go with that. Okay, so how are we going to actually write this value? So what we need to do is when our button is tapped, toggle LED, we send a message of some type. So let me go back over my code and just double check to see how I managed to make this happen with the firmware stuff. I think while we're here, we should do a read on that on the LED if we've got time for it, just because it'd be kind of cool to show that on the button, right? Like turn the LED on or off. I think it's in this other file. Let's do a search. Sending messages to the BLE device. Cool. Cool. I'm so glad I left myself some documentation. Yeah, I'll bring it across so there's something to look at. So the next, what we got? Haptics here. Yeah, so I've commented a lot of this stuff out. This is the code I'm pulling from. So we've got to discover services, haptic pulse service. Looks like that's kind of all we've got. Okay. Might have to open up, see a previous commit. Yes. That's all we got there. Let's take a look at the Bluetooth service. All right, sorry, bear with me, everyone. I've almost got this. Let's jump back to previous version of this. Then I can remove that. Awesome. Where is this? Trying to work out where I even had the code that's actually pushing information to the device here. Yeah, it's really weird. I'll find it. I'll find it. Let's go with the peripheral manager, and we'll just say. Huh. Okay. So I've got a classifier here that's making predictions and stuff for movement from the IMU, and then when a particular movement is detected, it's supposed to send a pulse to the haptics on the board. So that's what I'm trying to figure out, where I am sending that. Say matches service haptics pulse. Maybe it is under a different word, like buzz. Interesting. All right, so we might just have to look this up. That's okay. All right, so if I say, let's just do a CoreBluetooth write characteristics, and let's see what we come up with. So we've got here peripheral right value for characteristic. If that's all that is, oh yeah, that's easy. That was easy the whole time. Okay, so all I really needed to do was do a search for a right value here. So if I say, yeah, okay, cool. I must have deleted because the code went through a whole bunch of different iterations. It'll be on the repository somewhere. Let's just continue on with this. Okay, so what we got is, what we need to do now is when this is triggered, we go toggle LED, and then what we can do is we can say write. So we can say peripheral manager shared. We say, actually what we want to do, because I think the Bluetooth service has access to it. So it's the Bluetooth service. LED peripheral. We would need to go shared. And we just say write value, which will be our data. So we need to set up a data type for this. And I don't think we need to worry about our descriptor. Let's take another look at this. Write value for characteristic. Yeah, so this is correct. So the right type is, we'll say, we want the response so we can get the right so when we get, where is it? We get did write value for, I think we get a response here for that. So the characteristic will be our CB a characteristic. Let's do another search here. Right value. With response. Yeah, okay. So it looks like what we need to do now is keep track of that particular characteristic once discovered. Where is it? Just got our, scroll down here, we've got did discover characteristics for, and this is a characteristic here. This is a CB characteristic type. So if we just check out the documentation here real quick, let's see if we can, subclass represents further information about, in particular CB characteristic objects represent the characteristics of a remote peripheral service. So what we can do is, can we create one of these or not? Looks like we can't, so we're going to have to keep track of this. That's kind of annoying because the way I've got it set up here, what do we got? Yeah, it looks like we need to keep track of it in this Bluetooth service here. So what we'll do is we'll throw it up here. So next to the peripheral, we'll say LED characteristic as well. This is CB characteristic, and that will be an optional. And then again, we come down here and let's say we've got our, where is it? Bluetooth service, it's down here. Our Bluetooth service here, set notify value true. Got our characteristics. So what we'll do is we'll go Bluetooth service shared LED characteristic, and we'll set it here to our characteristic. Excellent. So what you could do here is we could do a check as well. So we could say, before we do this, we can say, is this the LED characteristic? Because what we're doing is it's every characteristic. We've only got one, right? But what you would want to do is like if characteristic dot, I don't know, where's the UUID? UUID is equal to the LED characteristic, then we can set it to the correct spot. So in this case, I'm not going to worry about that because we've only got one. So we've got the LED characteristic, it's all set up. Now what we can do is we come back up here and set some sort of data. So what we're gonna do is say this will be like a, we'll make it a string, right? So let's go with let's go toggle. We'll call it toggle. We'll call it toggle. And we'll say data using .utf8. I'm not sure if it's UTF-8. We'll have to double check that, but it should be okay. And then we go data here, and this will be our, let's go guard let characteristic equals Bluetooth service shared LED characteristic else return, and we'll say print could not find LED characteristic. Yeah, just so we get something printed out if this all goes wrong. Excellent. So the value type of optional, yeah, okay, so I think we can get away with that in this example. Just exclamation mark there. Okay, so what we need to do now is run this on a device. So let's just do a build, see if we get a building without it failing. Excellent. So I will run this on my phone. So we've got it selected up there. Also recently, it must have been like the last couple of Xcode versions, but Apple stopped allowing you to run it via the cable. So like you can plug it into your, you can plug it into your Mac and all that sort of stuff and it'll run, but it does it over the air for some reason, which is slower, the debugging. I don't know why they're kind of like, that's the default now. So I've got the app here set up. We are gray at the moment on the device and we just got a crash. What is this? Privacy. Okay, so what we need to do now is go into the plist and make some changes. So apps info plist must contain an NS Bluetooth always on. Excellent. So that means like the Bluetooth stuff's working, right? So we just got this error. So let's go in and fix this by adding a new value, and it is this one. We can say we want whatever we want here because it's not like it's going on the App Store or anything like that. So we can scan for the LED device. Cool. All right, so let's run that again. Yeah, the debugging and stuff's much slower now, and like sometimes I'll open up an app and then I'll like tap on it to go to a new screen. It'll just hang and just take like 30 seconds to do it because it's not running data through the cable anymore. So now we've got like the app called Light Goes On, says would like to use Bluetooth, and then the description is there so we can scan for the LED device. So if I say allow, you didn't see it. It was yellow for a second and then it's instantly gone green. So you can see here in the, so the device has been on the whole time, just sitting there waiting. We've got a green steady connection, which I am so happy about because I thought this was not going to work straight away. So what have we got here? Okay, so we got a green set up and we got our discovered my ESP32 at -53. Cool, so if we jump back to, I think this is still running, and we jump back here into our Arduino IDE, go to the serial monitor, we got setting up Bluetooth services, we got connected, so this has told us it's now connected. Wonder what happens if we tap toggle LED. Toggle, 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 toggle. How cool is that? So we've got like, it's printing out, so where's that word toggle coming from? It is coming from, oh, where is it? Oh, it's the string value that we've sent. So we've sent the word toggle, and that's the value that's come out. Cool. Okay, but we're not doing anything with it, right? So all we're doing is printing out that value. So the word toggle. So what we can do is we can say if, let's say, I'm so excited about this. I love this. Okay, so we find, so what we need to do is, so toggle LED build, oh, sorry, what do you mean by that? Keep going, keep typing. Okay. All right. So yeah, I've sent the data value of a string and we've converted it back here using this. So we can send numbers and stuff, and then we can say that this is an int. Turn on LED build and LED build ESP. Okay, yeah. So I can. Are you saying like I can want to change the value to something else instead of the word toggle? But in any case, so this is set up. What we do now is okay, so we probably need to keep track of a value. So let's say let's put it, because we want to keep track of whether the light is on or off. So let's throw in, say, let's go bool. Light is on, equals false. We'll default to a false. And then down in here we'll say if is on, else. Okay. So if light is on, we need to write to a pin, okay? So on this device, now this is something I get confused with a lot with these devices in particular, because you look up the chart of the pin out and it has like the pins, the number of the pins usually start like, and then they sort of like go around the board, right? Start at 1 and they go around. The pin number isn't always lined up with the actual, like whatever line is data line is going there. So the pin value is could be different to what the, let me show you what I'm talking about here. Most of us already know this, but for anyone new, you're probably not going to understand. So let me just grab Fire Beetle pin out diagram. Okay, I don't know if you'd be able to see this. This is the DF robot thing. I don't know if I can zoom in much further. Let's see. This should be okay. You're probably not gonna be able to read this text, but pin 1, we've got in out. Yeah, the IO is going to be different to the number of the actual pin. So when we are writing to these things, I get confused all the time, and every single time I always get it wrong. But what we're going to do here on this device is we want to respond by writing to a particular pin to increase the voltage, right? So what we do is, I think it's a digital write. So let's just look up. Yeah, so our pin, I think might be on, what do we set to here? Let me just check. We've got 20. So IO 19 is incorrect. It'd be like 34 or something. What we got? This is always an issue for me. If there's a fast, easy way of doing this, please let me know. We have this hooked up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh yeah. You said 12. So it's not 12 or 13. It's like 34 or something like that. LED build. Yeah, exactly. That, you're absolutely right. Yeah. So here, for if light is on, we want to set this to low, and then so we've got digital write, and then we can do the same here. Digital write. I think it's 34. We'll work it out. We set to high. So if the light is off, we set it to the value to high. So let's just go with it and see what we get. Oops, what have we done here? What have I done? Oh, it's switching between like languages and IDs and stuff. It's like confusing. It's gonna take a couple of seconds. But yeah, that digital write code, the LED built, yeah, that's exactly it. So is it LED built in? Is that something that I can use directly? Will that set the light on this board? Is there another light on here? Let me see, Fire Beetle. While this is happening off the side. Yes, okay. Okay, so maybe I won't need to worry about that other. I mean, we can always try both, can't we? Whoops. What have I done? What have I done? Is it really built in? It's getting late. Just, you know. Alright, where's this app? So, for some reason we haven't got the notification saying that it's like disconnected. I don't know, let's see what happens. Yeah, it's not updating there. See what we get. Yeah, not connected. So what I'll do is I'll close the app and relaunch it. Now we get a connected thing here with tap, toggle, toggle again. I'm not getting anything come through, so the pin is probably the incorrect, the wrong one. So what we're gonna do is I'll go with your suggestion. It's built in? Yeah, okay, let's try that. But I don't even know if there's a one on here. I've got a charging one and I've got this blue one. That turns on when that's powered. We'll see. I'll close the app again. Yeah, I think for the iOS portion of this, a little bit more work needs to be done as far as detecting like when things get disconnected and actually updating the colors. So I think, oh, actually, I think we can do that. We can do that right now. Because all we did was we did a print out, didn't we? That's all we're doing. We're not actually changing the state. So down here, we've got did connect, did fail to connect. This is where we should have the peripheral state set to error. And this one should be peripheral state disconnected. Okay. And then what we can do is we can also add a button to do another scan. So what is supposed to happen is when this is, to do this properly, did discover, what we want to do is say, since this is the only peripheral we're looking for, we want to go central, we want to say stop scanning. Yeah. And then what we can do up here is, since we got this scan for peripherals here, and this gets called on when this changes, I guess what we can do up here too is say, we can add another button, which is like scan for device or something. We can also say toggle LED. So in this function, so this, okay, sorry, I'm all over the place. So toggle LED, we come down here and we say write value. We're writing directly, but what we could do instead is say like, if this should actually be handled, all this code should probably be handled within the Bluetooth service itself. But here what we'll do is we'll say if Bluetooth service shared and peripheral state is not equal to dot connected, we can say Bluetooth service shared dot scan for peripherals guard else is equal to connected, else Ruby return. So what we want to do is, like, as we tap to toggle the LED, if the peripheral doesn't exist, or like it's not in the connected state, we're going to do a scan and we just back out of this and nothing will happen. So what we want to do now is put in a little print thing here and just say could not, peripheral not connected, we'll get back to the other stuff in just a second. Peripheral not connected, scanning again. Okay, so this way I don't have to restart the app, hopefully. All right, so let me open up my phone. Let's see what we get here. Should launch the app. Do you see that? It was like yellow and then it's gone green. That's cool. All right, so over here, it looks like if we clean that up, this should be running. If I tap, we get toggle. And built-in LED did not change. It's not changing at all. So it's not working on this particular device. So what I'll need to do is work out what that pin actually is. We're almost there, everybody. We're almost there. Just got to get this working. So the one that this is connected up to is on. Hang on a minute. I might be looking at the wrong device as well. That could be a possibility. Let's try a different value. Let's try 19. All right. We you know what we could do? Since I've got nothing else really connected, I could just do just for every value between 0 and 40. We can turn them all on and turn them all off. We're so close, we're almost done. Yeah, 20%, 22%, almost there. Yeah, so it's updating correctly now, so if you can see that. My face, so the color is like gray. If I hit reset on the, oh no, I shouldn't have done that. We were just compiling. That was really dumb. I was like, oh, hit reset and you see the color change. We gotta start again. Sorry about that. Oh man, I'm an idiot. Oh, what if I like broke it? Doing a reset mid firmware update is always a good thing to do. But I think it's got like a separate section on the device for firmware, and then it does a it applies the update once there's a restart. Thankfully, you know, for this reason, those idiots like me like to reset stuff while it's mid update. Too excited. Does anyone remember these? I picked these up the other day at the let me see that. Do you remember these cards? Anyone else get these when they were a kid? We're talking like late 90s. Found these at a collector's shop the other day. Well, as soon as I saw them, I was like, "Whoa!" It's an item that I completely forgot even existed. They're like glow in the dark and stuff. Anyone have those? What else have I got? I have like a whole bucket of vapes from I don't vape, but my friends do, and I plan to go through at some point and make a project where I'm just gonna rip all these rechargeable batteries out of them and then use them in something. Okay, so this is all set up. Cool, let's do a restart. It looks like the app has failed. Okay, so we're connected. If I tap this button, oh, come on. What have we done? So we got 19 doesn't work. Alright, I think I know what it is. Do one more attempt at this, 12. And I'll grab a couple others. And I'll set this to 13, I think. Yeah. Pretty sure the haptics are on 13, so even if the light doesn't work, we'll get something working. All right, last attempt. If it works. Last attempt if it works. But hey, the connection's working and we're still connected up here. It's pretty good. As soon as it starts uploading, that might change. Yeah, there we go. Disconnected. Got the grey color there. Disconnection. If there's anything else I can point out that I've got. I recently, something that I'm pretty happy about with is, let me see. Can't really show it to you because it, like, I've got to plug it in and stuff. So there was this guide online that I followed for like a set of like these animatronic eyes, and it's like all connected up, and it uses like a thumbstick thing and all that sort of stuff, and the eyes look up and down. There's a button to make it blink, and it's really cool. What I could do is maybe find it and put it in a link in the chat. So like if you're into doing all this sort of stuff, following along with the robot things, what would be really cool is to be able to control this, because this is controlled with an Arduino at the moment. It'd be cool to control it with an ESP32, and then like from an app, make it, you know, rather than having to have the hardware for it. So let's have a look at, it's already done. I'm gonna have to send you a link later. Okay. So reset, setting up Bluetooth services. This is on. Still not getting anything coming through here. What have I done wrong? Try a different sketch file, one that I've. So we got. Sorry, everybody. I'm an idiot. Yeah, here we go. So we've got. What number was it again? Yes. Okay. You need to specify if we're doing an out. Pretty sure we got to pass these through. That's annoying. Really sorry about that. So we need to come down into the setup. And we need to set these pin mode output. I believe that's, I think, is that correct? You got to set them to be output, but they're automatically set to input. That's the way that works, isn't it? It's not the other way around. They're not automatically outputs. Yeah, you got to specify them to be outputs. All right. So what we've got on our setup here, we've got 13 and 12. We've got 20, 13, 12, 23, 19, 13, and 12. All right, let's try this again. Be great if I could like trim out all this stuff on YouTube, but unfortunately not. You have to skip around to find the good stuff. Okay, let's do another compilation, see what we get. If this doesn't work, I have one more thing for us to try. Just trying to see if I can find a better pinout diagram because it doesn't have the pin numbers on it, the one I was using. This one might be better. Alrighty. So blue is searching. To close that down and reopen. Here we go. Alright, let's try this one last time. And then I think I might give up. So we've got, what have we got here? Let's try these values. So we've got analog read. That's for audio. So I was pulling in audio. And these need to be output too. So we set these in the setup. All right. One last compile. What I'll do is for next time, I'll set up the platform, the other IDE, so we don't have to sit around waiting for this compilation stuff. Yeah, I couldn't find a good pinout diagram. It's got IO12, IO13, which is none of these values. And 0, yeah. Anyway. All right, let's go one more time, and then do this. Okay, cool, that works. Yeah, so I had the pins wrong. The pinout diagram that we had didn't give us, where is it? So here we've got the IO 14, 13. These are the ones that are hooked up to, well, one of them is hooked up. So it's the 12, I believe, IO 12. But that's not, you know, if you want to activate that pin, like there's no 12 here. So this is what I was talking about before. I was getting really confused. You have to actually get the whatever pin it is down here. So it's like 1, 2, 3, 4, or wherever the actual pin sits. So we are using pin 19, I believe, on this board. Okay, so anyway, you can hear the vibration from it because I've got the haptics up there. So that's been activated as well. So if you can see the LED is on. So let's put that where you can see it. See the LED. If I tap, should turn off. Not turning off. Because I'm just I'm just an idiot. Man, live streams, excellent. I think I'm doing okay, right? So like, I would assume that most people that have like perfectly fashioned videos make so many mistakes and they always get edited out. I think we got it. I think we got it this time. If the light is on, we set it false. Yeah, okay. Here we go. Now we can do the check. I think what we could also do is like check the pin output as well. We can toggle based on that. I don't know. We'll just go with this. What I will do is I'll make all this code available. I don't think I need to clean it up too much. I think we've gone through and done quite a bit of that. It's fairly straightforward. In fact, I feel like you would learn more just looking at the code than sitting through 2.5 hours of me talking about it. There wasn't too many big revelations this time. Like usually when I'm talking about this stuff, I'll take a lot of sidetracks and I'll be like, hey, don't forget to do this, or the reason why we're doing it this way is because of this. That the main takeaways really is knowing that you have to keep a reference to your peripheral, and you have to scan you have to scan the peripherals, you have to scan the services on each peripheral, and you have to scan for all the characteristics. That's the main thing. Everything else is just callbacks like delegate methods and things like that. It's really kind of like, it's kind of straightforward after all that. Just don't get tricked up on like the pins and stuff like me. All right, here we go. So we can turn the light on, we turn it off, on, off, by just tapping our button. Yeah, it's all coming from here. I'm not using my foot on anything to turn this light on or off. It's legit coming from the device. It's pretty quick too. So like tap, tap, tap. It's like instant. It turns on before I can lift my finger off the button. How cool. Pretty happy with that. So that's a success. If you want to, so at the moment we're sending the word toggle, so we can do a check on that. Of course you can also send anything else. So if you want to send like RGB values, this is just a green light from what I understand, so we can't really do anything with that. When it comes to RGB values, I don't know how we go about the digital write. So I assume instead of low or high, you can pass through data, perhaps. I haven't got that far in this in my experiments and stuff like that with it, but what I know that I'll need to discover that when I start building an app to control these eyeballs. Yeah, so the whole point of this project was because what I wanted to do was put these in like a toy or something and just have like sit on the shelf, and then I wanted to put like a camera in there. I think I mentioned this on a previous stream, and it kind of just like looks at you as you move around the room and stuff. And then I wanted to like gaslight people when they came over and just be like, hey, they'll be like, oh, is that thing looking at me? I'll be like, no, what are you talking about? It's just a toy. But it would follow them around. Okay, I think that's it. 2.5 hours. I know it was a little bit long. I feel like we could have shortened that up a bit if I had the video and edited it down. But I'm hoping that the long form stuff is what is most useful, because you actually get to see the struggles as we go through this together, and we learn a lot. You can learn from my mistakes anyway. I'm going to what I'll do is let's just cut this down to like, I think, and then like the code that I put up will just be this basically. So, and you can make the changes as needed. The code for the devices themselves is really short. It's like less than 70 lines really of code to get this working, to listen to an event that's coming through. You can probably shorten it up even further if you got rid of all these print statements and stuff. These output pins and things. So you gotta remember to do that. Yeah, so what is it? Like probably like 55 lines of code. When it comes to the iOS portion of everything, we have, this is all done in one file, and we've got less than 200 lines of code, which is pretty cool. I think Apple could do better when it comes to like the available APIs for this sort of stuff, but these are old, right? So these have been around for a while. I don't know if they've made too many improvements in recent years to it. It works, so they don't need to really fix it. It's pretty good. It's not super low level stuff like you would expect. Usually when there's like missing documentation or not many tutorials online for a particular subject, it's always like low level stuff. This is pretty well documented. It's pretty good. It's just the nature of the whole scanning and all that sort of stuff is just a little bit weird compared to what you might be used to with working with, communicating with a server or something like that. It's not the same thing. It would be cool if it was, but I understand their reasoning for why it's a little bit different, because there's some security concerns and stuff like that you need to be aware of with these devices. Like you got these UIDs. If you get access to that, you sort of know what data it takes. You can kind of like talk to any Bluetooth device. That could be a fun project as well. Just like seeing if I can create an app to control the nano leaf lights that I've got. Replace their version of the app. Who knows? But yeah, there we go. So we have our haptics and an LED lighting up on this thing. And the cool thing is too, like if I unplug this, let's see if this works. Yeah, so I've now gone wireless, no cable plugged in, and the light can turn on and off. Can you see that in the light there? Barely. Let me there we go. How cool. That's it. That's all I've got. I'm done for the night. I am going to go and probably play some retro games or something like that to chill out. But thanks for coming along and watching. It's been requested a lot. I think the majority of the people who wanted this video will probably watch it later. It's a Friday night here for me, so I understand that there's not very many viewers. But thanks for those who came in and had a little bit of a chat. I will be back soon with something else. I noticed that the videos that I was doing on the astrology app kind of like people lost interest in it, because I think it was like episode 7, and I've personally lost interest in it myself. So let's do something new and something cool on the next one. Anything you want to see covered, any topics like that, just send me a message. I will see you all later.